Alright, so this is the example from lecture about how we reverse a list and how we deep copy a list using recursion. And so first I'm going to implement a shallow copy, a regular copy. I'll just call it regular copy, so that we can get a little bit of intuition about why deep copy is important for it to be recursive. So how would we copy a list? Well, we have our list here, items, and then maybe I'll say copied equals that, and then for item in items copy dot append item. Okay, and then we're going to return copied. What is the problem with this? Well, it's should be fine if all of our items inside of this items list are immutable, like integers or strings or something. So for example, we have our global context, which is the main section of our Python program. And let's say we have a list called stuff. And that list points somewhere in memory to this guy. And that has a bunch of things in it. Maybe that's 1, 2, 3, high, 17.5, etc., etc. And then when we call regular copy on our variable stuff, then we're going to have our copied list, which is going to be a new list. I'm just gonna duplicate that. Alright, and then we're going to go through and basically say for every item in items, which is our original guy, then we're going to add that here. And so we're going to be pointing to all the same things in memory as we were before. But then it doesn't really matter because 1 is not going to change. 2 is not going to change. It's fine. The problem is when we start to have lists or other mutable data inside of our list. So let's say instead of 17.5 as the last element of our list, then instead of that, I'm going to get rid of these pointers at the end for ease of viewing. Instead, we had a list that had 3 elements. And that's 1, 2, 3. Okay. And so now you can probably see the problem here. When we copy our list, we have another pointer for the copied list, like one element of the copied list, pointing to the exact same list in memory as the original one. Which means that if we do like stuff, and then this is index 0, 1, 2, 3, 4. Okay, stuff at index 4 at index 0 equals high, then this is going to be changed to high, and then crap, our copied list is also changed. So this is not what we want. That's why we want a deep copy, where we'll also get a copy of this nested list. And why is that an inherently recursive problem? Well, we're going through copied here, and instead of doing, let's say we run across one of our items that's a list. Oops. Well, what do we want to do to that list? Well, we want to copy the list. And that's exactly the same mechanism as how we copied the list up here. And so we're going through copying each element of the list, and then if we find that one element of the list is a list, we want to go through and do the exact same thing, copying every element of that list. Hence, what we can do is we'll say if type of item is list, then instead of appending just the item to the list, we're going to do copy.append regular copy of our item. And then once it makes a copy of the item, then that's what it'll append to the list. Otherwise, we'll just append the item as is, because we know that it is one of these immutable types, or like one of these primitive types that we care about, and not another list. Cool. Now that we have that recursively, this is no longer a regular copy. We can call this a deep copy because it works now. Amazing. Okay,